time I try to debug my mind, my code's a riddle, you always rewind. You find the errors in every nested loop. Oh, clever llama, master of the code. You solve our mysteries just like I was told. VFDs and VLCs, you know them well. Edge and my secrets, you never.
Welcome back. Today's video is the third video of the Basic AMC Template series. In this video, we're going to talk about the differences between hardware version 1 and hardware version 2 function blocks. Did you know that there are two versions of each of these drives? That's correct. Each one of these drives has a hardware version 1 and a hardware version 2 variant of the drive. However, most people probably didn't know that there were two variations of the drive because both the hardware version 1 and hardware version 2 of the drive have exactly the same functionality. They have the same parameters, the same setup, they look the same, they fit the same space, they are the same drive. So what's different between hardware version 1 and hardware version 2? The difference between hardware version 1 and hardware version 2 is the code size. Hardware version 2 has a lot more code space in Machine Control Studio for you to use than hardware version 1. Knowing this, the template system has made special blocks for hardware version 1 to save space and special blocks for hardware version 2 to gain more functionality. In this video, we're going to show you some differences of the two. Here in front of you is Machine Control Studio. And you can see that I have the new project window opened up. And you'll also notice that there is a hardware version 1 variation for ladder logic, and a hardware version 1 for structured text, and a hardware version 2 for ladder logic, and a hardware version 2 for structured text. So the question is, do you have to use hardware version 1 drives if your code was written for hardware version 1? No. The only thing this does is select which versions of the blocks you want to use. I highly recommend that if you're going to write code for a hardware version 1 drive, that you use hardware 1 version blocks. This is because it's going to save you a lot of code space. If you have a hardware version 2 drive, you can still use hardware version 1 code if you want to save additional code space, especially if you don't need the extra functionality that's given to you by hardware version 2 blocks. Now, if you're going to write a piece of code that lives in an MCI 200 module or an MCI 210 module, you don't need to worry about which version of the drive you have. That's because all of the code lives inside the module and not the drive. Please note that the MCI 210 and MCI 200 have even more functionality than hardware version 2 drives. For example, the MCI 210 module has a block that allows it to talk to other drives. That, of course, is not built in to hardware version 2. Let's show you some of the differences. When you create a project, it'll look something like this. This is what hardware version 1 project looks like when you first create it, and this is what hardware version 2 project looks like when you first create it. To help you see both of them at the same time, I have stacked the two projects. On the top half of this window, you'll see what the code looks like for hardware version 1. And on the bottom of this window, you'll see what the code looks like for hardware version 2. So what we're going to do is just kind of describe why this line of code exists, and just to show you that the blocks look different. We're not going to go into a lot of detail, but I do think it's important for you to understand why this line of code is here. One thing to note is this line of code is primarily used to set up the AMC so that you don't have to. And this line of code does exactly the same thing. It just sets up more of the AMC. So let's look at it one step at a time. So the first contact here is a positive edge with the word true. What this does is makes this line of code only run one time. Again, you see the very same thing right here. So basically, this is a one shot. The next block basically stops the AMC from moving, okay? Basically, the next block just enables the AMC and puts it into absolute mode. If you don't have absolute encoders, you could set this to false. It really doesn't matter that much, but that's what this block is doing. The next block here is called AMC user units. but the block down here is called AMC control. As you can see, this block AMC control doesn't even exist in this ladder rung. And this is because this block takes up a lot of code space, and because hardware version 1 doesn't have as much code space, it's been opted to be removed from the initialization. So I'm going to just delete this block here so that the two rungs look exactly the same. So now we have AMC user units up here and AMC user units down here. You can see that there are less settings on this version of the function than there are on this version of the function. This version of the function only sets up the user units and which direction is the positive direction. This function block has both of that, but it also can choose what units are for velocity, and it can also set up rotary rollover mode and a few other things. This block, AMC master units, sets up the user units for the master encoder or whatever's coming into the drive. Again, it has the distance per encoder turn, which direction is the positive direction, and also a source, like where is this encoder source coming from. This block has exactly the same functionality. Then the very last thing this ladder rung does is gives the drive a run command so that the drive is allowed to send power to the motor. As you can see, both hardware version 1 and hardware version 2 basically have the same things going on. The real big difference is the AMC user unit block. So the main question here is, do you have to have this line of code in your program? The answer is no. You can completely delete this rung of code out of your program and it will cause no problems. You could delete this one completely and it won't cause any problems either, unless you are using non-standard AMC units. This block, if you were going to set it up as AMC user units here, and also AMC units here, then you could delete this ladder rung as well. But if you're using any other units like RPM, or if you're using acceleration units as milliseconds, then this block cannot be deleted. You could still delete this block, you could delete this block, you could even delete this block, and your code would still be okay. That's because all of these blocks are really doing is just setting up settings in the drive. And so if all of the settings are already correct in your drive, then this ladder rung isn't really that important, other than maybe giving your drive a run command at the end. The exception is these two here. And that's because in the background, it's setting up some scalar units that are in the blocks that automatically scale between RPM and AMC user units. So this is the block that's doing that for your logic. And so if you get rid of it, then your project will automatically go to the AMC standard units on power up. So that's really the difference between hardware version 1 and hardware version 2, is mostly this AMC user units block and the way it causes all the rest of the blocks to behave. As you can see in the POU section, there are a lot of blocks that use velocities and accelerations, and so it does affect a lot of things. But as far as the number of blocks here, they're the same number of blocks, so functionality wise they have exactly the same thing, as long as you're just writing code in the base drive. Now if you're writing code in the MCI 210 module, there are some additional blocks, but that's because the MCI 210 module has some additional functionality that the base drive doesn't have. Thank you for watching this video. If you found this video helpful, you might want to check out the next video of the series. You can find this video by clicking right here. In the next video, we're going to talk about how to set up the user units so that all of your units are in inches or degrees or whatever.